All right, okay. Now, so today we are going to go through paper 2, Melaka, okay, the trial paper in the year 2022. Okay, now let's look at the very first question here. Let me zoom out there. Okay, we've got table 1, which shows the number of protons and the number of neutrons in atom P, Q, and R. Okay, so atom P, Q, and R, it has number of protons 11 and 11 for both P and Q, but it has different number of neutrons. Okay, when it has different number of neutrons, this makes that P and Q are actually an isotope. Okay, they are isotopes. And then R, it has number proton of 17 with the number of neutrons, which is 18. So, okay, let's look at the first question. A1, state one subatomic particle present in the nucleus of an atom. So, this one can be either one. Okay, can be either proton or neutron. Okay, that is what actually the subatomic particle which is in the nucleus of an atom. All right, now let's look at question 2. Which atoms are isotopes? Give a reason for your answer. So you have to name both atoms P and Q. Why? Because they have same number of protons and different number of neutrons. Okay, if you fail to mention the first part, the same number of protons, you will not get your second mark. Okay, you have to mention one set, number of same number of protons and different number of neutrons as one set of mark. All right, now B1, state the valence electron of atom R. So when we write down the electron arrangement, we normally use the number of protons to write down the electron arrangement. And in this case, the number of proton for R is 17, which makes the electron arrangement for R is 2.8.7. So the question was the number of valence electron. So the number of valence electron will be 7. Okay, next, draw the electron arrangement of atom R. Okay, when you draw the electron arrangement, you have to make sure R is circled to indicate that R is actually the nucleus of the entire atom. Okay, then only you start drawing the electrons. And basically, atom R, the electron arrangement is 2.8.7. Okay, now that's for question 1. Now let's go on to question 2. Diagram 1 shows an advertisement selling a type of cocaine gas cylinder. Basically, this one actually is the latest. Okay, it's quite an expensive cylinder. Okay, because why? It's very light. Okay, the first composite cylinder in Malaysia. It's rust-free. It does not explode and it absorbs shock. Okay, so this one actually I've seen some way whereby this cylinder, right, you can actually lift up with just one hand, and then when you throw it down, it doesn't explode. Okay, and it actually absorbs shocks. Okay, now let's look at question 1. State the meaning of composite materials. So what is a composite materials? Composite materials will be materials made of combination of 2 or more matrix substances. Okay, let me material made of the combination of 2 or more matrix substances. Okay, and strengthening substance or non-homogeneous substance. That's the definition. Now you can't run from definition. You definitely need to remember what are the definition of all the things or the terms that you use in chemistry. Okay, now to state another advantage of the composite materials used in diagram 1. So another advantage you can see is very obvious that it is light. Okay, that is why the lady can actually carry the cylinder. All right. 3. Give one example of composite material. All right. Give one example. It can be any example. It can be reinforced concrete. Okay. The answer can be reinforced concrete. Oh. Reinforced concrete. Okay. It can be fiberglass. Anyone. Okay. You don't have to name so many actually. Okay. You can just name one. Fiberglass. Okay. Any form of composite material can be accepted as an answer. All right. Let's look at the next question. B. High-speed train that uses the concept of magnetic levitation concept can achieve a maximum speed up to 600 km per hour. State the type of alloy used that enables the concept to be used on high-speed train and give a reason for your answer. So this one is actually the type of alloy that they use is superconductor. Okay, is superconductor. Now, many students might say you never learn this or it's not anyway, but this one, part of the question is the clue is from, oops, the clue is actually magnetic levitation concept, okay, and then you can achieve a maximum speed, and then it is used on high-speed train. So this is a superconductor. Okay, being the reason why does this happen? Okay, because it does not have no electrical resistance at a very low temperature. Okay, so it's very important that you know some of this application of uses. Okay, because it can be asked in the question. Nowadays our questions are all high order thinking skills question already basically, so you need to know at least some. All right, okay, now moving on. Let's go to question 3. Empirical formula. Okay, I bet most of the students, they love this type of question because it should be a bonus question for you. Okay, now diagram 2 shows the apparatus set up to determine the empirical formula of magnesium oxide. A. While carrying out this experiment, why does the crucible lid need to be opened once in a while? Okay, why? To allow oxygen to enter the crucible. So we need oxygen inside. Okay. If not, we cannot burn. Okay. Magnesium to enter the crucible. Okay. Next, B. These are the results that you get, okay, from the particular experiment, and it is shown in table 2. Okay. Now, first, you are to calculate the mass of magnesium. So if you notice here, this is just crucible and lid. So basically, it's just crucible and the lid itself. This one, crucible and lid with magnesium. This one is when it's with oxide, magnesium oxide. Okay, it has turned into a white solid. So how do we calculate the mass of magnesium? So we need to take 28.75 minus 26.35. You just need to count lah. You use your calculator and count it out. You should get 2.4 grams. All right, what about oxygen? You have to take the one with magnesium oxide, okay, minus the one with magnesium ribbon. Then you will get 1.6 gram. Okay. Now, calculate the number of moles of magnesium and oxygen. Oxygen. So number of moles of magnesium is equals to 2.4 divided by 24, because we found the mass just now, which is 2.4 grams. So this is 0.1. Put your final answer, mole. Okay. Now, number of mole of oxygen, it will be 1.6 divided by 16, which is 0.1 mole. Your final answer must always have unit, because why? If you don't have unit, even if the method is correct and your answer is correct, okay, you will not secure any marks, okay, due to this reason being that units are to be stated every time you are doing what is that, paper 2. Okay. Now, determine the empirical formula for magnesium oxide in the experiment. So you don't have to do that table that we always do, because this is only 1 mark. So you just need to straight away write down the answer as MgO, because it's quite obvious already. We know magnesium 0.1, oxygen also 0.1. So the simplest mole ratio here will be 0.1. Okay, this is the smallest number of mole. So again, when you took ratio magnesium to oxygen, it will be 1 to 1. That is why it's MgO. Okay, very easy, right? Question 3. Now we're going into question 4. Okay, diagram 3 shows part of the periodic table of elements. What is the element represented by the symbol Fe? This is iron. There is no other answer which you can actually replace, only iron, the correct answer. Okay, you cannot put other answer, right? Now, write the electron arrangement for magnesium atom. Okay, when you are given situation like that, whereby you do not have the number of protons to guide you on writing down the electron arrangement, identify first which group is it in. Like in this case, it's in group 2. So you know that it has 2 valence electron, and magnesium is located in the 3rd period. So if it's in the 3rd period, it must have 3 shells filled with electrons. So for magnesium atom here, the electron arrangement will be 2.8.2. Okay, now C, let's look at C now. Statement below shows properties of 2 types of gas. All right, helium will be light, not reactive, colorless. Hydrogen, light, flammable, colorless. Based on the information above, okay, which gas is suitable to be used in meteorological balloons? Give a reason. Okay, so normally in meteorological balloons, we will choose helium gas. Okay, I know the fact that hydrogen is lighter compared to helium, but hydrogen is flammable gas. That is why we choose helium. So the gas suitable here will be helium gas, because why? It is not reactive. Okay, sometimes your answer can be short and sweet. Keep it short and sweet, okay? Because when you tend to start to lengthen your sentences, it will make your answer look so wrong sometimes, okay? Now, D. Mrs. Chin is a hairdresser in a salon. Mrs. Chin found that after her client's hair was washed, the hair was sticky and difficult to comb. State the name of the hydrogen bond form. The moment you see hair sticky, paper when wet, okay, it's become like it will stick into surface. These are all hydrogen bond. Don't think too far, okay? You've got only 2 situations. This is also given in your textbook, okay? basically on the application of hydrogen bond in our daily life. Okay, now explain the effect of the bond on Mrs. Chin's client's hair. So how are you going to explain? Firstly, you have to explain when the hair is wet, okay, protein molecules form hydrogen bonds with water molecule. So first thing is you have to mention when hair is wet, okay, hydrogen bond, okay, hydrogen bond, protein molecules will form hydrogen bonds with water. Okay, how to get the third mark? Okay, the third mark is water molecules form hydrogen bond with the hair protein molecule. Okay, so hydrogen bond forms the with the protein molecule in hair. Okay, so that's how actually hydrogen bond is formed. That is why when your hair is wet, right, it sticks between to each other. Okay, so that is for question 4. Okay, now let us continue by looking at question 5. All right, diagram 4 shows a series of reactions that occurred on compound X. So when you are given this type of diagram, is same goes to chapter salt. Okay, so you don't make things worse by keep reading the question. Instead, you approach the diagram immediately. Okay, so like in this case, you know that compound X, when you add hydrogen with 180 degrees Celsius and nickel, basically compound X must be an alkene. Okay, because only alkene will have all these reactions. Okay, and this is memang is what a hydrogenation process. Okay, so if alkene undergoes hydrogenation, we will form an alkane. Okay, now if it undergoes reaction 1, okay, we've got H3PO4 and next 60 atm and 300 degrees Celsius. Okay, compound Z would be more of something which an alcohol, okay, because normally alkene to become alcohol it has to undergo hydration. Okay, hydration. Okay, so this one is actually alcohol. Now at the moment we still haven't identified what is the name of all these substances yet. Okay, all these compound. Okay, now if you see reaction 2, there is polypropene here, meaning your alkene at compound X is actually a propene. Okay, a propene. So definitely compound Z will be propanol. And compound Y will be propane. Alright? And reaction 2 is what we call the addition polymerization. Okay? Polymerization. At your stage, you need to mention what type of polymerization. You cannot just mention polymerization already because you are learning 2 types. One is the condensation polymerization and another one is the addition polymerization. Okay, now let's look at what the question is. A, compound X and compound Y is a hydrocarbon. What is meant by hydrocarbon? So hydrocarbon, you need to mention it's an organic compound Okay, organic compound which contains carbon and hydrogen only. That is why it's called a hydrocarbon. Okay, now B, both compound X and Y are suitable to be used at food and can produce a sooty flame. Which compounds will produce more soot? Explain why. So compound X and Y both can actually be used to burn. Okay, so if you got alkane and alkene, okay, normally the compound which will actually produce more soot will be compound X. Okay, compound X, which is an alkene. Because why? Okay, you have to answer the question first. Compound X. Because why? You can actually mention the percentage of carbon. Okay, the percentage of carbon in compound X is higher than compound Y. That is the reason. The real reason is because of the percentage of carbon. Okay, that actually because the carbon is the one that actually contributes to the soot. All right, now that's for B. B2, write the chemical equation for the complete combustion of compound in B1. So in B1, okay, it did not mention here which compound. All right, it did not mention which compound. So meaning if you were to say you want to take X, can also, but normally the question is more referring towards X. Okay, so compound X is propene. So C3H6. C3H6 plus O2, you will definitely have a yield, a product of CO2 and H2O. Okay, being the formula CHO, we will balance out the carbon first. Carbon, we've got 3 here, so you just add 3 in front of CO2, followed by hydrogen. You have to see the hydrogen towards your left is 6. So the other side, it has to be 6 as well. So that is why you add 3 in front of the H2O. Okay, now let's count the number of oxygen now on your right. Okay, we've got 6 plus another 3, which is 9. Okay, so normally if you have odd numbers for alkene, your odd number will turn into fraction, which is 9/2. Okay, because you find that it cannot be balanced. Oops, sorry, it cannot be balanced properly. So the only way is to turn it into over 2, which is in fraction form. Okay, now C1. Okay, identify compound Y and compound Z. So like I said just now, if you attack the diagram very early, you already know what the answer is. So in this case, compound Y is propane, compound Z is propanol. Okay. Now, next, 2, draw the structural formula for the monomer of the plastic bottle. So the plastic bottle here, they have already drawn the polymer. So this is the polymer. So you are to draw the monomer out. Okay, the monomer. So it's a polypropene, meaning your monomer will be, okay, C double bond C. It has to be 3 carbon because it's propene. It comes from propene. Okay, H. Now remember, this carbon atom has 1, 2, 3 bonds already. So H. Okay, 4. So this carbon atom also have 2 already. So you need H and H. So this is the monomer of the plastic bottle. Okay. So that's it. So if you notice, the question can consider quite easy lah, okay? But what matters is you need to really master the topic, then only you can proceed in answering your questions. Otherwise, it will be problematic. Okay, now let's look at question 6. Diagram 5 shows the information for two products using two types of acids, acid X and acid Y. Okay, so it's pickled using acid X, where X is a monoprotic acid and its value is pH 4.8. You always remember, if the acid is used to make pickles, there's none other than ethanoic acid. They won't use other acid. Normally very standardized is ethanoic acid. Okay, now for lead acid accumulator, it has a pH 1, and the moment you detect there is diprotic acid here, you will not learn other diprotic acid except sulfuric acid. Okay, only sulfuric acid. Now let's look at the question. A, state the meaning of acid. Acid is what? A chemical substance that ionizes in water. Okay, so acid is a chemical substance that ionizes in water to form hydrogen ions. Okay, you can just put H plus only, because H plus alone is already indicating it's hydrogen ions. Okay, identify acid Y. Sulfuric acid. Okay, sulfuric acid. Now, C. Both acids X and Y have the same concentration. Explain why the pH values for both acids are different. So first you need to mention that, okay, acid X is a monoprotic acid, whereas Y is a diprotic acid, meaning X produces 1 mole of hydrogen ions upon ionization. Okay, Y produces 2 moles of hydrogen ions. Okay, so ionizers you already written one time, so it's okay if you've forgotten to write second time. And then finally you have to say the concentration of H plus in X is lower than Y, which is why the pH value for, okay, so to make sure you are safe, so you can actually mention the pH value. It's my pen. The pH value of Y is lower than X. Okay, this one is to back up, to make sure you can actually get your full 3 marks. All right, now let's look at D. When 0.5 mole zinc carbonate is added into excess acid Y, effervescence occurs. 1. By using acid Y stated in 6b, write the chemical equation for the reaction. So we've got zinc carbonate reacts with acid Y. So H2SO4 plus zinc carbonate, ZnCO3. You will get zinc sulfate plus CO2 plus H2O. Let us check out if this is actually balanced. So Zn1 SO4, so 1. CO2. Okay. H2O. So this is balanced. So the first mark is for being able to write the correct reactants and the correct products. And the second mark goes to the number of moles stated in front each chemicals in the particular chemical equation. Okay, that's how you secure your 2 marks. Now, let's look at how we calculate the volume of gas produced at room condition. So in this case, you are given 0.5 mole of zinc carbonate. Okay, so first thing first, you need to mention this step, which most students always forget. You have to say 1 mole of H2SO4 reacts with 1 mole of zinc carbonate to form 1 mole of CO2. So if this is 0.5 mole of, actually which one? Oh, sorry, 0.5 mole of zinc carbonate, meaning 0.5 mole of CO2 also produced. So the volume of gas is equals 0.5 times 24. So this thing, the answer will be 1.2 dm cube. Okay, sorry, 12 dm cube. Aish. 12 dm cube. You have to make sure you write down the correct unit, otherwise big problem. No marks. Okay, so your first mark goes to where? Let me guide you. Your first mark goes to mole and ratio. Okay, mole and ratio. Like that. Okay, so mole and ratio first mark, and your second mark goes to your answer. All right. Okay, let us go on to the next question. Oops. I have to pull off my mouse because it's got problem with it. Okay, now let's look at question 7. This one is salt. Okay, again, I mentioned just now, you deal with hydrocarbon, you straight away go to the diagram. Okay, don't keep on reading and reading too much. In the end, you don't know what you read. Okay, then, okay, next you have to analyze the diagram. Same goes to this chapter, salt. Okay, now let's look at diagram 6. It shows a flow chart for the reactions undergone by zinc chloride. Okay, basically zinc chloride produces zinc carbonate here with solution Q. Okay, later on, then we go. Zinc carbonate reacts with HNO3. We will get zinc nitrate. And then the colorless gas will be CO2. Okay, now we got not enough info to actually answer solution Q and solution P. All right, so what do we see? Let's look at okay, first question first. Is that the solubility of zinc chloride? So solubility meaning here he's trying to ask you whether is it soluble in water or not. So it is a soluble salt. Okay, now next, based on diagram 6, all right, identify solutions P, Q, and R. Okay, so we have to go back and look at this thing. So we want to produce zinc carbonate, okay, with solution Q. So solution Q has to be another salt, okay, because why? Zinc carbonate is actually an insoluble salt. Okay, this is insoluble salt. Insoluble salt. So when you have insoluble salt with a solution, normally this one will be a soluble salt. So our favorite normally lah, we like solution P to be maybe you can name it as because why? You are dealing with carbonate, so it must have carbonate and ion. And normally all carbonates are insoluble except the triple NK. So you can choose sodium, okay, sodium carbonate, or you can say sodium carbonate. Okay, for Q, because you know that Na2CO3 sodium carbonate has already reacted with zinc chloride, so you will get zinc carbonate and sodium chloride, NaCl. Whereas for solution R, let's look at solution R, we have already mentioned just now, which is zinc nitrate. All right. Now, state the type of reaction for step 1. So just now, step 1 is involving 2 soluble salt to form 1 soluble and 1 insoluble. So this is what we call the double decomposition. You can also call it as precipitation. Either one of the answers are accepted. Okay, now 3, write a chemical equation for the reaction that occurs in step 1. So in step 1 just now we have sodium carbonate with zinc chloride. Okay, zinc chloride reacts with sodium carbonate to form sodium chloride plus zinc carbonate. So let us see the balance part. Balancing part, it seems like your sodium need a 2 in front. So again, first mark is for correct reactants and correct products, and the second mark with balancing of chemical equation. That's how you get your full mark again for writing a chemical equation. Now, for calculate the mass of zinc carbonate produced when 0.1 mole ZnCl2 reacts with solution P. Okay, just now our P is Na2CO3, right? Okay, so we've got, we want to calculate. Okay, let us rewrite this particular chemical equation. Okay. It doesn't hurt to write more, but make sure the things that you write is correct. Don't simply write, Okay, now they ask you to calculate the mass of zinc carbonate produced. Mass, wow, this one only 1 mark. 0.1 mole of this one. So if you see here, actually the ratio is the same. So because this is only 1 mark, you just straight away calculate the mass, which is 0.1 times the RMM of zinc carbonate, which is 125. So you will get 1.25 grams. Okay, so that's the amount of zinc carbonate which was used up, okay, during the experiment. Okay, now let me count it again. Okay, 0.1 times. Oh, sorry, 12.5. You see how we depend on calculator nowadays. 12.5 grams. Okay, now next 5. Draw a labeled diagram of apparatus set up to carry out experiment in step 2 and show how colorless gas is tested. So you have to show how colorless gas is tested in this case. Okay, so let me show you the diagram. How is it done? Right? So this is your diagram. Make sure it's labeled. All right, it's labeled. Okay, now how do you get your marks for this one? We've got 2 marks here. Okay. You must make sure this delivery tube is in the lime water. Okay, and then you have to make sure that you are using the correct chemicals. Okay, all the correct chemicals will be 1, and then delivery tube is connected in with a stopper there. Okay, that's to get 2 marks. So that's 2 marks for this apparatus setup. All right. Okay, now let's look at question 8. Diagram 7 shows a plant that widely used in traditional medicine. Based on diagram 7, so this is aloe vera, isn't it? Okay, A1, state the use of plant in traditional medicine. So normally in traditional medicine, it is used to treat wounds. Okay, to treat wounds or any to treat wounds or any skin irritation. Okay, now how can the plant be used for? Meaning he's trying to ask you, how do you use that plant? Okay, so you can actually crush the gel substance. Okay, crush the gel substance and apply on wound. Okay, that's simple. Now, B, various types of affordable cosmetic materials are available in the market, but there are some of the commercialized cosmetics that contain harmful chemicals which can cause harm to consumers. 1. State one effect of harmful chemical substance to consumers. One of it would be, normally very basic, is skin irritation. Okay, because some cannot take it. Okay, is skin irritation. Okay, the face will start getting itch and then become reddish. Okay, with what do you call that, allergies. Okay, because of the skin irritation. Now, 2, Ministry of Health Malaysia and National Pharmaceutical Regulatory Agency are responsible to supervise and approve the use of ingredients in commercialized cosmetics. As a consumer, justify the uses of approved commercialized cosmetics in daily life. So you have to justify. Justify meaning you need to mention, okay, why do you support it can be used? Because in this answer is already towards positivity, whereby it had been tested clinically, so it can be used up. So first you can say commercial cosmetics is approved by cosmetics is approved by Ministry of Health. That's the first justification. Okay, to support this, all right, what can you say? It can protect consumers from harmful side effects. That is why it has been done. The clinical test has been done. Okay, it can protect consumers from harmful side effects. Okay, harmful side effects. Now, next, let's look at C. Table 3 shows 3 types of cosmetics, P, Q, and R with its uses. So P is to beautify the face, Q to treat the body, R to provide fragrances. Based on table 3, give an example of P, Q, and R. So P will be compact powder, lipstick. Okay, they are asking you to give an example, so not to worry. It can be lipstick, you can say actually eyeshadow, all these things. All right, there's no limitation to the answer. Okay, and then Q will be cream or face moisturizer. Cream, normally face moisturizer, lotion. Okay, now R to provide fragrances, this will be perfume. Okay, deodorant, perfume. So you'll be lucky enough if they ask you to give an example. If they ask you to give the substances inside, it will be difficult. All right, so that is a 3 marks question. Now let's look at D. Mei-Ling notices sudden acne breakouts on her face. She is attracted to an advertisement for an anti-acne product that claims the acne could disappear within 5 days. What steps should Mei-Ling take before purchasing the anti-acne product? Now, firstly, of course, you have to identify the ingredients used. She needs to identify the ingredients used because there are products in the market which is not clinically tested, actually contains mercury inside, and this is hazardous to our health. Okay, so secondly, ensure that the product has been registered, okay, with Ministry of Health. So you have to make sure that the product is registered with Ministry of Health. Okay, so it's that simple. Actually, this one is more of consumers' right. Okay, you need to know all this. So that is all for section A. Okay, question 1 to question 8. All right, we're coming into question 9 here. Okay, so let's look at question 9. So this question 9 is a vortex cell actually, and it shows the apparatus set up for 2 cells, cell 1 and cell 2, which is connected together. And basically in this particular cell, we find that zinc is from where we should start, okay, labeling our our entire circuit. Okay, so now zinc is at negative terminal, okay, which makes it an anode. Okay, whereas because these two particular solutions are connected using the salt bridge, which makes copper a positive terminal. All right, now then next we have both W and X, which is the carbon electrodes. Okay, now later on then we will look into cell 2 lah. All right, but let us look at what the question is given first. Okay, you are given a part of the standard electrode potential half cells. Okay, now 1, based on diagram 8.1 and table 4, state the function of salt bridge in cell 1 and identify the negative terminal in cell 1 and explain why. So like I said just now, so what's the function of salt bridge in cell 1? So salt bridge is actually to make sure the ions are keep flowing. Okay, so it actually allows the movement of ions to complete the circuit. Okay, so it actually allows the movement of ions to complete the circuit. Okay, next, you are to identify the negative terminal in cell 1, which is obviously zinc. Okay, so the negative terminal will be zinc. And why does this happen? Okay, it's because of the electropositivity, or in other words, we can actually use the E0 values here given. okay, whereby the E naught values of zinc is more negative compared to copper. Okay, so the E naught values of zinc is more negative compared to copper. That's what makes it a negative terminal actually. Okay, now 2, let's look at 2. So that means 1 mark for allows the movement of ions to complete the circuit. Point 2 is zinc, and point 3, E naught value of zinc is more negative compared to copper. Okay, next, let's look at part 2. Explain the reaction that occurs on carbon electrodes W and X in cell 2 based on 1. Movement of ions to each electrode, choice of ions to be oxidized and reduced, and the reason why the ions were chosen, half equation at each electrodes, and the observations at each electrode. Okay, so let us look at how does it happen, W and X. So in W, it's because it's at the positive terminal. Okay, positive terminal. Okay, it's in positive terminal, and X is in negative terminal. So obviously positive actually attracts negatively charged ions, which in this case we are using copper 2 chloride solution. Oops. So because we are using CuCl2, so we've got 4 type of ions available here, which is the Cu2 plus ions, you've got H plus ions, hydroxide ions, and also the chloride ions. Okay, so because this is at positive, so it will attract chloride and hydroxide ion. Okay, but obviously hydroxide will be chosen due to the E naught value compared to chloride ion, unless it's stated here it's a concentrated solution. Okay, but normally if it is 1 mole over dm cube, all right, normally if it's 1 mole over dm cube is considered a rather very concentrated solution. So as a result, we will normally go for chloride ion. All right, we will go for chloride ion. Now, let us plan the answers nicely. Okay. Okay, so we've got the first part here. So these are the answers actually. Now, I'll explain to you how does this goes about. Okay, so firstly, in electrode W, hydroxide and chloride ions will be the one that attracted to W. All right. In X, we will find copper 2 ions and also hydrogen ions attracted to X. Okay, and each of these carries 1 mark. All right, each of these carry out 1 mark. Now, normally we will tabulate it so that it looks more organized and systematic and easier to be read. Okay, so in this case, so this one will be the first one, this one will be the second one. Okay, and then you are asked to choose which particular ion will be chosen. So in W, Cl minus will be chosen. Okay, chloride ion will be chosen. And in X, copper 2 ions will be chosen. Okay, why? The fact that in W, the concentration of chloride ion is higher than hydroxide ion. Okay, but in X, why is copper chosen? Due to the E naught value, which is more positive compared to hydrogen. Okay, and then this is the half equation. Somehow half equation, you can get it from the E naught value, the particular series given. And of course, chlorine has a greenish yellow gas. Okay, it's greenish yellow gas, and whereas for copper is in brown solid form. Okay, so that's how you get your full score of 10 marks here from this particular question itself. Okay, now let's look at question B now. Question B is about diagram 8.2, which shows the apparatus setup used in the lab to investigate the reactivity of metals towards oxygen to form metal oxide. Okay, so actually potassium manganate powder, manganate 7 powder is used to be heated here in order to produce oxygen gas. All right, we have a glass wool here to make sure that the oxygen gas does not escape through too fast. Okay, otherwise it can, once the potassium manganate 7 powder is heated up, it will produce oxygen so fast that it can escape out very fast. That's why we need a glass wool there to withhold the oxygen gas. Okay, now when iron is heated using the apparatus in diagram 9.2, iron 3 oxide is formed. State the color of iron 3 oxide formed and write a chemical equation for the reaction. Calculate the mass of metal oxide formed when 14 grams of iron is heated. Okay, so how is this question done? Particularly, we know already, if iron 3 oxide in the form of iron 3, anything which has iron 3 ions is normally brown in color. Okay, so that one, the color is brown. Now, then you have to write down the chemical equation, okay, between the reaction. So we got 4Fe, okay, Fe reacts with oxygen to form Fe2O3. So we have to do balancing. So when you do balancing, you get 2 here, 4 and 3. So that's a balanced chemical equation. Okay, we will utilize this particular chemical equation to do some calculation. All right, now given 14 grams of iron is heated, okay, and then we want to calculate the mass of iron 3 oxide form. So of course, definitely we will go for number of moles first. In chemistry, is always number of moles. So number of moles of ferrum is 14 divided by 56, which is 0.25 mole. Okay, 0.25 mole. And then from the equation, we know that 4 moles of iron produces 2 moles of iron 3 oxide. So in other words, 0.25 mole of iron will actually produce 0.125 mole of iron 3 oxide. So the mass of iron 3 oxide will be equal to 0.125 mole multiplied by the RMM of Fe2O3, which is 160. Okay, and then you will get your final answer, which is 20 grams. Okay. So, okay, now,
So for the first answer you give was 1 mark, and then you've got the color lah, the color of 1 mark, and then you were asked to write chemical equation, 2 marks there. All right, chemical equation here, that means mark 2, mark 3, and then we got mark 4 here, mark 5, and then mark 6, and your final 7th mark here. So that sums up the 20 marks from question 9. Okay, now we're going into question 10 now. Question 10 is basically a rate of reaction question, which by right, if you are given this question, you should try to score as high as possible marks. Okay, so let's look at what the question is about first. Okay, now 3 sets of experiment are carried out to determine the factors that affect the rate of reaction. Table 4 shows the reactants and time to collect 40 cm cube of gas for set 1, set 2, and set 3, right? A. What is meant by rate of reaction? And state 2 factors that affect the rate of reaction. So basically, when you are given table like that, not only in hydrocarbon, in salts, but also in rate of reaction, normally we will go for the table first. Okay, so in this case, first, the set 1 is normally a control set. Okay, so set 1, if comparatively with set 2, there is a difference there whereby the concentration is involved. And then if we were to compare with set 3, it will be the size of reactant. Oops. Oh, okay. Size of reactant. Okay, so what is meant by rate of reaction? The meaning is that is the change in quantity of reactants per unit time. So you must have this thing here, there. All right. So you must have the word per unit time because that indicates actually this is the rate of reaction. Okay, and 2 factors here will be concentration of hydrochloric acid. Try to state as specific as possible because normally we will know what will happen. All right. Okay, and the other one will be size of calcium carbonate. Okay, so that's 3 marks. Now B, draw an apparatus setup for set 1. So you have to draw the particular setup for set 1. So it's actually a water displacement technique. Okay, water displacement technique. So the diagram is something like that. Now, what are the requirements which you must have here? Okay, let me tell you. Right, you have to make sure that this particular tube here is below the water level. All right. Okay, and make sure your burette is filled up with water, and it is actually connected to a conical flask which is closed tightly. Closed tightly meaning the rubber here has to be slightly above the mouth of the conical flask. And then you have to make sure a hydrochloric acid and marble chips, okay, or CaCO3 is reacted here through a delivery tube. So that is the whole diagram of what is the apparatus set up for this particular experiment actually. All right. You don't have to draw a stopwatch because it's not necessary. Unless you are asked to write a procedure, then you need to mention about stopwatch because we do know how important a stopwatch is in rate of reaction experiment. Okay. Now, C, write a chemical equation for the reaction and calculate the actual volume of gas released in set 1. So what happened? The chemical equation here will be HCl plus CaCO3
we will get, oops, okay, let's do the other side. Okay, knock this one out again. Okay, so we've got HCl just now. Let me change this one to black one. Okay, HCl plus CaCO3. Particularly, we'll get CO2 H2O, and our salt will be CaCl2. Okay, so we need to do some balancing here to make sure everything is balanced. Okay, so HCl is not, so you have to add 2. So now it's all balanced. So this is your balanced chemical equation. Now you have to calculate the actual volume gas released. Okay, so how much of gas is released? Volume, how much? Okay, given set 1, you've got 25 cubic cm of 0.4. Okay, so volume of 25, molarity is 0.4. So again, in chemistry, it is always about calculation of mole. So number of mole of HCl equals to mv over 1000. Okay, which is 0.01 mole. Okay, so obviously from the equation we know 2 moles of HCl produces 1 mole of CO2. In other words, 0.01 mole of HCl produces 0.005 mole of CO2. Okay, so the volume of CO2 will be 0.005 multiplied by 24. Okay, so you get that's your answer for question C. That's 5 marks there. All right. Now, definitely when it comes to rate of reaction, you will find question like this. So you are now to compare the rate of reaction between the sets of experiment, and you have to explain your answer also based on collision theory for set 1 and set 2 and set 2 and set 3. Okay, how do we go about this particular question now? Right. So normally, okay, I will go for table. Okay, I will love table. So let's go for table. I will encourage table because table are a way whereby you can actually see what's going on in everything. Okay. So we've got set 1 and set 2 first. So like I said just now, we already know the difference. Oops, she's so bended. But anyway, sorry. I'm unable to draw such straight lines actually. Okay, rate of reaction. We definitely know, okay, if comparatively set 1 and set 2, okay, we can see that the rate of reaction in set 1 is much higher compared to set 2. So in 1 is higher, lower. Okay, so now next you have to write down the concentration of hydrochloric acid. So this one is higher, that one is lower. Okay, so when you have concentration of HCl, normally we will stress on the number, okay, of hydrogen ions per unit volume. Okay, so this one is higher in set 1 and it's lower in set 2. Okay, so due to the number of hydrogen ions per unit volume, the collision, okay, between H plus ions and calcium carbonate, this is definitely higher and the other one is lower. As a result, the frequency of effective collision, okay, between H plus and CaCO3 is definitely higher in set 1 compared to set 2. So if you see here, if you were to use table, it's so much easier because why? You sum everything up in column 1, which is basically the title for the entire for the table. So how do we put our marks? Normally, comparison here, you already get 1 mark. Second mark from concentration. Third mark from because we know that it's more concentrated. As a result, the number of H plus ions per unit volume is actually higher. So as a result, the collision between H plus ions and CaCO3 is higher, and frequency of effective collision is much higher in H plus, between H plus and CaCO3 in set 1 compared to set 2. Okay, now let us look at the next one, which is you are asked to compare between set 2 and set 3. So the only difference we can see here is the difference is that one is in powdered, one more is in granule. Okay, so obviously this time is size. Okay, size concern. So set 2. Maybe initially when you want to find out the particular topic which is suitable for column 1, it might be a little struggle at first, but once you get used to keep doing this type of question, it wouldn't be an obstruction for you anymore. Okay, it won't be a challenge anymore lah. All right, so now we have set 2 and set 3. We know that the rate of reaction here, if comparatively in figure form, we know that set 2 has a higher rate of reaction compared to set 3. Okay, now the size of CaCO3. Don't forget to mention specifically. We don't use the word reactants. We try to mention as specific as possible the type of reactant that we are using in this particular experiment. So in this experiment, we are using CaCO3. So we mention that the size of CaCO3 is, don't forget, is smaller. Don't get tricked. Okay, so this is bigger. So as a result, okay, you don't have to use the total surface area anymore because the total surface area is actually explaining back the size of CaCO3. Okay, so you can actually say the number of CaCO3 per unit volume, or actually to be more on the safe side lah. Okay, we can use total surface area also, no harm. Sometimes we also don't feel secure, right? Okay. Even I also don't feel secured actually. So total, we just put in total surface area just in case. Okay, total. Okay, total surface area of CaCO3. So it's obviously in 2 is bigger compared to, higher compared to set 3. Okay, so number of CaCO3 per unit volume, this is of course higher compared to set 3. As a result, the collision between CaCO3 and H plus ions. I prefer to use H plus ions because normally it reassures us, okay, comparatively to just writing down the name of the acid just so randomly. So as a result, frequency of effective collision between CaCO3 and H plus ions, it's higher compared to in set 2 compared to set 3. Okay, let's look at how the marks are like. Okay, so oh yeah, okay, rate of reaction of course carried the 6 mark. All right, then the size, that's the factor. Okay, like I said, size and total surface area, they carry almost the same mark. Okay, they carry the same mark. And then number of CaCO3 per unit volume and the collision, and as a result the frequency of effective collision. Okay, then again I add in total surface area to be more on the safety side. Okay, in case it tops up any parts, okay, maybe it will be changed to another part. Okay, we never know. So in order to play it safe, we always put in as much details as possible that we know regarding this particular factor. Okay, so that is for question 10. All right, now that's it for question 10. Okay, we are done with another 20 marks. Okay, you see how fast it can go. I mean, is that as simple as that possible? Okay, so let's look at the final question, question 11. 11a is table 6.1 shows the equations and heat of neutralization for two sets of experiment, set 1 and set 2. Okay, so we got so on, so on. What is meant by heat of neutralization? And state the type of acid used in set 1 and set 2. So the meaning of heat of neutralization, we know basically neutralization is formation of water. Okay, but how water is formed? Okay, water is formed from acid and alkali. So heat, okay, in this particular question, you are to tell how is it that, okay, the meaning of the heat itself. So heat change or release when 1 mole water is formed from the reaction between acid and alkali. Okay, so state the type of acid used in set 1 and set 2. So set 1 is a strong acid, set 2 is a weak acid. All right, so it's quite obvious here because the moment you see ethanoic acid, if they want you to name what type, is normally either weak or strong. Okay, so that's for question 1. Question 2, in set 1, 50 cm cube of 1 mole over dm cube, sodium hydroxide solution reacted with 50 cm cube of 1 mole over dm cube of hydrochloric acid. Calculate the highest temperature reached if the average initial temperature is 28.5 degrees Celsius. Okay, so now we are to calculate, all right, so from set 1. Okay, set 1 we are given negative 57.3. Yeah? All right, let's jot down all the details. Okay, for question 11. All right, we've got NaOH. We'll get NaCl plus H2O, and delta H is equals to negative 57.3. All right, and then you are given 51. All right, 1 volume 50, molarity 1, volume 50. Okay, and then he said the average initial temperature, theta initial is 28.5. So we want to calculate the theta highest is how much. Okay,
Now, so first, when we are given this type of question, we will calculate the number of moles first. So either one, because both has the same concentration, both has the same type of volume. So number of mole will be 1 times 50 divided by 1000, which is 0.05. Okay, 0.05 mole. So in other words now, okay, your delta H meaning you got 57.3 kilojoule for 1 mole. Okay, so in other words, 0.05 mole produces how much of heat? So that is why we take 0.05 times 57,300. Reconvert it back to joule. Okay, because why? When we first calculated our MC theta, it was in joule form. Okay, that is how you get 2865 joule. Okay, and don't forget your MC theta. Your M here will be 100 because of 50 plus 50 times C 4.2 times your theta, which is your temperature change, equals 2865. So as a result, theta is equals to divided by 6.82 degrees Celsius. But you are not done, because why? You are to calculate the highest, meaning 28.5 plus 6.82, which is equals to 35.32 degrees Celsius. Now that is the answer. Okay, 35.32 degrees Celsius. So this particular calculation carries 4 marks, which is why if you look at it, it's quite simple. It doesn't need you to crack much. Okay, so first it will go here, this mark. The second mark will be here, third mark, and your final mark. Okay, that is why it's only 4 marks. Okay, let's look at question B. Now you are given diagram 6.2, which shows energy profile diagram for 2 types of reaction, reactions 1 and reactions 2. Okay, so reaction 1 is heat of precipitation. Okay, and then reaction 2 will be, oh, it's an endothermic reaction. Okay, now, so based on table 11.2, okay, compare reactions 1 and 2 based on the type of reactions, heat change during reactions, temperature change, total energy content of reactants and products, and change of heat energy during the breaking and formation of bonds. So this is like 5 marks. Okay, how is this done? Right. Let me show you basically when we tabulate it out, what does it look like? Okay. This is how it looks like when we tabulate out. Okay, how? So first, we need to tabulate out differentiating these 2 particular reaction. That means you've got reaction 1 and reaction 2. Reaction 1 is an exothermic reaction. Reaction 2 is an endothermic reaction. And then in reaction 1, heat is released. That is why there is an increase in your thermometer. Okay, that is why temperature increase. Okay, in reaction 2, it's endothermic, whereby heat is absorbed. Okay, that is why the temperature actually decrease. Okay, that is why you observe the temperature on the thermometer actually drops. So the total energy content of reactants is higher than total energy contents of products in reaction 1,
Whereas in reaction 2, total energy content of products is higher than total energy content of reactants. And lastly, heat energy released during bond formation for products is higher than heat energy absorbed during breaking of bonds in reactants. This is in reaction 1 because this is exothermic. Okay, in endothermic, heat energy absorbed during the bond breaking of reactants is higher than heat energy released during formation of bonds in products. So basically all come in one pair, 1 mark, second mark, third mark, fourth mark, and the fifth mark. Okay, it looks like there's so much to memorize, but what you need to stick in your mind is that exothermic, it releases heat. Then from there you know what is going on. All right, so that's for question C. Okay, let's look at the last question. Oh, sorry, question B. The last question. This one shows a self-heating container to heat food. The pack is filled with calcium chloride powder and packed together with water. Okay, you are supplied with a few chemical substances like magnesium nitrate, calcium oxide, and ammonium nitrate that may be used to replace calcium chloride powder. Plan a method that could be done in the lab to choose which substance that can be used to replace the calcium chloride powder. State how you choose which substance is suitable to replace the calcium chloride powder. So firstly, you need to know calcium chloride powder functions as a what? Okay, it actually heats up the thing. So you have to plan out a method, okay, a method in the lab itself. So what is it like? Okay, so okay, so this is what it looks like actually. Why is this not working? All right, so first you will need to measure 50 to 200 cm cube of water and pour into a polystyrene cup. Then you put in a thermometer into the polystyrene cup. Record the initial temperature of water. Add a spatula of magnesium nitrate into the polystyrene cup. Stir the mixture. Record the highest or lowest temperature reached. Okay. Repeat using calcium oxide and ammonium nitrate. So substance that has the highest temperature change is the most suitable to replace calcium chloride. So you have to state the method that you are going to use first, then which particular one can be used to replace calcium chloride. Okay, so that's it on how do we go through this type of question. This can be a really tough question depending on how we look at it. If you are used to doing this type of question, it shouldn't be a problem for you lah. Okay, so anyways, that's all for Melaka Melaka Trial 2022. After this, we will go on to 2 more, which is the year 2023 trials. Okay, so stay tuned for it.